Hello class, today we're going to do section 1.3, linear functions. Our objectives today are to identify linear functions, find the intercepts and slopes of graphs of linear functions, to graph linear functions, to find the rate of change of a linear function, and to apply linear revenue, cost, and profit functions. Alright, let's start with the definition. A linear function is a function that can be written in the form f of x equals ax plus b, where a and b are constants. Now, we want to determine whether each equation represents a linear function. Now, a says 0 equals 2t minus s plus 1. Now, keep in mind that we want to put it in the form where we basically have something like f of x equals ax plus b. And a lot of times we'll let y represents f of x, so we want it somewhat in the form that looks like y equals ax plus b. Okay. Now, can I convert a into a form that looks like that? Well, sure. What if I just do something simple like add s to the other side? Okay, then I'll have s equals 2t plus 1. That looks very similar to y equals ax plus b. So a should be a function, okay? A linear function at that. The equation 0 equals 2t minus s plus 1 represents a linear function because each of the variables are to the first power, and each is a separate term. Solving the equation for s equals 2t plus 1, like what we just did. Now, how about b? b is y equals 5. Now, with y equals 5, this really could be the form ax plus b, because in this case the a could just be 0. 0 times x is 0, which would just leave you with the y equals 5. So the equation y equals 5 is in the form of y equals ax plus b, where a equals 0 and b equals 5. So it represents a linear function as well. Now, how about c? In c we have xy equals 2. Now let's try to get y by itself. I'm going to divide by x to do so, so I'm going to get y equals 2 over x, but x is in the denominator. The equation xy equals 2 does not represent a linear function because x and y are not separate terms, and the equation cannot be written in this form, y equals ax plus b, because you see when we try to do that, the x wound up in the denominator, not the numerator, and we had an issue. So that is not a linear function. Not a linear function. Let's look at finding intercepts algebraically. To find the y-intercept of a graph, y equals f of x, we want to set x in the equation, or equal to 0 in the equation, and solve for y. If the solution is b, we say that y-intercept is b, and the graph intersects the y-axis at the point 0, b. On the contrary, in order to find the x-intercepts of the graph of y equals f of x, we set y equal to 0 in the equation, and we solve for x. If the solution is a, we say the x-intercept is a, and the graph intersects the x-axis at the point a0. Alright, so let's do some examples of finding intercepts algebraically. Oh, southern accent's getting to me. Find the x-intercept and the y-intercept of the graph 2x minus 3y equals 12 algebraically. Now with the y-intercept, we set the x part here equal to 0. So that's why we're setting the x part equal to 0 in order to find the y-intercept. Kind of opposites there, right? So 2 times 0 is 0, which leaves you with negative 3y equals 12. And then if you continue to solve for y, you'll see that y is negative 4. All they did was divide by negative 3 there. 12 divided by negative 3 is indeed negative 4. So our y-intercept of our graph here is negative 4. If we wrote that in interval notation, it would be 0, comma, negative 4. Let's look at the x-intercept. For the x-intercept, we will let the y be 0, just like we did here. Okay, both of these we're just setting it equal to 0. So we got 2x minus 3 times 0 equals 12. Well, 3 times 0 is 0. That just leaves us with 2x equals 12. You can see they divided by 2 here, so x equals 6. So our x-intercept is 6. If we wrote this in interval notation, it would be 6, 0. Or not interval notation, but point notation. Okay, xy. So we have our x-intercept, we have our y-intercept. They were very easy to solve algebraically. You can also see here it says the graph crosses the x or y-axis at 0, -4. The graph crosses the x-axis at 6, 0. And we have found those. Very, very simple. Alright, let's look at the loan balance. It says a business property is purchased with the promise of paying off a $60,000 loan plus the $16,500 of interest on this loan by making 60 monthly payments of $1,275. The amount of money Y remaining to be paid on the $76,500 loan, the loan plus interest, is reduced by $1,275 each month, because that's the amount you're paying towards it. Although the amount of money remaining to be paid changes every month, it can be modeled by this linear function. Y equals 76,500 minus 1,275x, where x is the number of monthly payments made. We recognize that the only integer values of x are from 0 to 60 to apply this application. Basically, you can make no payments. You can make up to 60 payments. Once you've made 60 payments, you've paid your debt off. The equation no longer applies. Okay. So, we want to find the x-intercept and the y-intercept of the graph of this linear equation. Alright. Now, if I'm looking to find the x-intercept here, I'm basically setting the y equal to 0. And keep in mind, I'll go back to this. Here's your equation. Y equals 76,500 minus 1,275x. So once again, the x-intercept sets the y equal to 0. And I'll even write the equation up here for you. Y equals 76,500 minus 1,275x. Nice. We are setting the y equal to 0 to find the x-intercept. We're solving for x. So what I did was add 1,275x over to the left-hand side. I then divided by 1,275 in order to get x by itself. And I see that, hey, x equals 60. That is our x-intercept, which kind of makes sense because after 60 months we have paid off everything and our balance is now at 0. Let's look at the y-intercept. The y-intercept is where I need to set the x equal to 0. So y equals 76,500 minus 1,275. I set the x equal to 0. 1,275 times 0 is 0, which just leaves me with the 76,500, which is the amount you will have paid on the loan. That is our y-intercept. Let's interpret the intercepts in the context of the problem situation. I've kind of done that a little bit already, but let's make it official. The x-intercept corresponds to the number of months that must pass before the amount owed is $0. Therefore, a possible interpretation of the x-intercept is the loan is paid off in 60 months. The y-intercept corresponds to the total loan plus interest that must be repaid 0 months after purchase. That is, when the purchase is made. Thus, the y-intercept tells us that a total of $76,500 must be repaid. How should x and y be limited in this model so that it makes sense in the application? Well, we know that the total time to pay off the loan is 60 months. A value of x larger than 60 will result in a negative value of y, which makes no sense in the application because I'm not going to continue to pay on a loan that I have paid off. So, the values of x vary from 0 to 60. That's kind of your domain, right? The output, y, is the total amount owed during any time during the loan. The amount owed cannot be less than 0. And the value of the loan plus the interest will be at its maximum, which is $76,500, when the time is 0. Thus, the values of y vary from 0 to $76,500. That is your range. Okay? That's how x and y are limited. X and y are limited, domain, and range in these ways according to this particular problem, right? Let's look at D. D says use the intercepts and the results of part of C to sketch the graph of this given equation. Okay, So let's just say I had this graph over here on the right hand side and it did not already have this blue line on it. Because the blue line is technically what we're supposed to be trying to graph. We can use the intercepts to graph a line because all you need to graph a line are 2 points. And what better 2 points than the intercepts, right? The first intercept here is our x-intercept, 0, 60, which is why the first initial dot's technically put here. The other intercept we had is 0 and 76,500, which is right here. And then you can just draw the line between the two right here. The blue line between the two there. That is the line from this particular equation. We have now graphed it using the intercepts because it's linear, which means it's a line, which means you only need 2 points to graph it. And if you already have the intercepts, just use those. It only exists on that particular domain and range as well, because remember, the domain of this is from 0, which is technically here, to 60, and the range is technically from 0 to 76,500. So this particular graph window captures this domain, and we can see the entirety of the graph. All right, let's look at the definition of the slope of a line. The slope of a line is defined as slope equals the vertical change over the horizontal change, or you may have heard it as rise over run. The slope can be found using any 2 points on the line. If a non-vertical line passes through 2 points, P1 with coordinates x1, y1, and P2 with coordinates x2, y2, its slope, denoted by m, is found by using m equals y2 minus y1 over x2 minus x1. And you can look at the graph over here on your right hand side and see that we're basically looking from this P1 to this P2 point here of your change in x and your change in y. Your change in x is your run, your change in x, or y is, your change in y is your rise, your change in x is your run. Ooh, little tongue twister there. Changing your y is your rise, changing x is your run. We put your rise over your run, and we have your slope. Okay, that's simply found by subtracting the y values and subtracting the x values. All right, the slope of a vertical line now is undefined because x2 and minus x1 is 0, and a division by 0 is undefined. And the slope of a horizontal line is 0. Okay, now, just for these little caveats right here. Okay, slope of a vertical line is 0. Okay, if I were to draw a vertical line, right, look something like that. Slope is 0 because if we think about rise over run, if we rise from this point to this point, let's say we've risen 3, but we've runs to the left or to the right, right? Okay, we have run 0. Anything divided by 0 is undefined. Oops, and that was a very terrible underlining of the word undefined. Don't even know. Here we go. Okay, but this is undefined because we can't divide by 0. Whereas if you think about a horizontal line slope is going to be 0, because if we look at the rise from this point to this point, we rise 0, and let's say the run is 3. 0 over 3 is 0. 0 divided by any number is 0, which means that the slope of a horizontal line is slope equal to 0. Okay. Let's do some examples calculating the slope of the line. Okay. Find the slope of the line passing through the points -3, 2 and 5, -4. Okay, let's use the formula. Remember, y2 minus y1 over x2 minus x1. Okay, easy enough. This is, I'll make sure I line it up right. So this is going to be your x1, this is going to be your y1, this is going to be your x2, this is going to be your y2. Easy enough. Okay, so if you see this, we do your x2s and your y2s first. So your y2 goes on top, the -4 goes on top, -2 divided by 5. minus negative 3. Now keep in mind when you have a minus a negative, it turns into a positive, so this is technically 5 plus 3 on the bottom, which is where the 8 comes from, and negative 4 minus 2 gives us the negative 6 overall. We reduce that fraction to negative 3/4, and that is our finalized slope. Hopefully that's not too hard for you. It's just plug and chug. Right, you do have to know and memorize this slope formula, but if you know the formula, you can outline the points, the answer turns out just fine. Technically, it doesn't matter which one you call x1, y1, and x2, y2 as long as you stay consistent within the parentheses. You can't have an x1 and a y2 in the same parentheses. As long as they're both x1, y1, x2, y2, you'll be fine. Let's look at the relationship between orientation and the slope of its line. Okay, slope is positive if the line rises upwards towards the right. So if you look at the picture here, the right hand side, you can see we have this upward slope to the right. Upward slope to the right means we have a positive slope. The slope is negative if the line falls downward towards the right, which is what our other picture looks like here. The line's going downwards towards the right. Okay, rise here, fall here. Okay, positive slope, negative slope. Simple enough. The slope of a horizontal line is 0, just like what I went over earlier. Slope of a horizontal line is 0 because a horizontal line has a vertical change, which is a rise of 0 between any 2 points on the line. So horizontal slope, 0. Remember, M represents your slope. Horizontal slope is 0. Vertical slope is undefined. The slope of a vertical line does not exist because a vertical line has a horizontal change or run of 0 between any 2 points on the line. Alright, the slope and y-intercept of a line. The slope of the graph of the equation y equals mx plus b is m. And the y-intercept of the graph is b. So the graph crosses the y-axis at 0b. Simple enough, right? Okay, slope of the graph of the equation is y equals mx plus b. Hopefully you've seen and heard that before. M is the slope. B is the y-intercept. That simple. So let's determine the slope and y-intercept of the linear function. Okay, A says y equals 7x minus 12. Solution. Which one's the slope? Which one's the y-intercept? Take a second now. Identify it yourself. Luckily, the first equation is written in what we call slope-intercept form. The slope is 7. The y-intercept is negative 12. The slope is the one that's on the x. The y-intercept is the constant. We're done. But B says 2x minus 3y equals 12. Okay. This is not written in y-intercept form. And because it's not written in y-intercept form, we can't just pull out numbers. We have to instead put it in y-intercept form. So let's look at how we do that. Okay. Putting this in y-intercept form. Now, I'm going to do it out to the right just in free write form because I feel like it's easier to follow if I actually work it piece by piece. But you can see it worked out already to the left. Essentially, you can work it the way I did it on the left. That's fine. I'm going to work it a different way over here on the right. I'm going to subtract 2x in this one. So I'm going to do negative 3y equals negative 2x plus 12. And then I'm going to divide by negative 3 on both sides. So I'm going to have y equals 2/3 x. And then 12 divided by negative 3 is negative 4. Okay, so I'm going to have the equation y equals 2x over 3 minus 4. That's how I would solve it. You can solve it like this by moving the negative 3y over to the right hand side, then moving the 12 over to the left hand side, then dividing by 3. You essentially get the same thing. There are multiple ways to solve pretty much all of the questions that you'll have this semester, as long as you solve it correctly in whatever manner you choose. As long as you don't choose to cheat. Don't want you to cheat. But if you're doing a legitimate method and you get to the right answer, it's fine. I don't force you to do everything an exact certain way. If you're doing it a technical, correct way, even if it's not the way I showed, that's fine as long as you get the right answer. Alright, still have to identify what the slope and the y-intercept is. The slope in this one, once you get it in the slope-intercept form, is 2/3. The y-intercept should be the negative 4, and you do have to keep the sign with it. You do have to keep the sign with it. Okay, that's why it's negative 4, not just 4. Alright, let's look at loan balance. This one says the amount of money Y remaining to be paid on a loan of $60,000 with $16,500 of interest is Y equals 76,500 minus 1,275x, where x is the number of monthly payments that have been made. What are the slope and y-intercept of the graph of this function? Come on. It's already in slope-intercept form for the most part. Okay. The slope should be the number in front of the x, including the negative there. And the y-intercept should be the constant. So, you can adjust your form if you want to put it in technical y-intercept form. Okay, because technically in y-intercept form, the slope term needs to come first with your variable, and the y-intercept needs to come second. So if we rewrote it in technical y-intercept form, we would have y equals negative 1,275x plus 76,500, meaning that the slope m is negative 1,275, and the constant term 76,500 is the y-intercept, your B. The amount of money, y, remaining to be paid on a loan of $60,000 with $16,500. Interest is y equals 76,500 minus 1,275x, where x is the number of monthly payments that have been made. How does the amount owed on the loan change as the number of months increase? Well, we've seen the graph for this. What happens as the months increase and you make payments? Well, the amount owed on the loan goes down. It's pretty clear by the graph, I think. If we look at the individual months and what the amount owed is after each month, when we say look at the first 6 months, you could tell that the amount owed decreases after every month because we make a payment. So the slope indicates that the amount decreases by $1,275 each month. Makes sense, right? We have our debt, paying $1,275 each month. So each month, the amount of debt we owe goes down by $1,275. Which leads us to the constant rate of change. The rate of change of a linear function y equals mx plus b is the constant m, the slope of the graph of the function. What you'll find is slope has many different names. They're all the same thing. They all want the same thing. They just want slope. So if they ask for the slope, it wants the slope. If it asks for m, it wants the slope. If it asks for the constant rate of change, it just wants the slope. Alright, let's look at this example. Hispanics in the United States. Using data and projections from 1990 through 2050, the percent of Hispanics in the U.S. population can be modeled by h of x equals 0.224x plus 9.01 with x equal to the number of years after 1990. What is the slope of the graph of this function? The slope should be the number that's in front of x. The number that's in front of x is 0.224. The coefficient of x in the linear function h of x equals 0.224x plus 9.01 is 0.224. So the slope of the line is 0.224. Don't overcomplicate it. Look like a complicated question. All it's asking for is the slope. Give them the slope. This is the slope. This is your answer. Very nice. All right. So what does the slope tell us about the annual rate of change in the percent of Hispanics in the United States? Well, the slope tells us that the percent has increased by 0.224 each year since 1990. The percent has increased by 0.224 percentage point. Okay. So, not even 1%. Not even a 1% increase. A 0.224% increase. Okay. So that is a percentage of a percent is what the Hispanic percent has increased. But that's what the slope tells us. Let's look at marginal revenue. A company produces and sells a smartphone with revenue given by R of x equals 89.50x dollars. And cost given by C of x equals 54.36x plus $6,790. Where x is the number of smartphones produced and sold. What is the marginal revenue for the smartphone and what does that mean? Remember how I just told you that slope has many different names? but they're all asking for the same thing. If they ask for marginal revenue, marginal cost, marginal profit, they're just asking for the slope of those respective functions. So the marginal revenue is the rate of change, or slope, which is the slope of the graph. Thus, the marginal revenue is $89.50 per unit sold, which means that the sale of each additional smartphone will result in an additional revenue of $89.50. So the marginal revenue is $89.50 because that is the slope of this revenue function. R of x equals 8950x is the revenue function. Just so I write it all out on one line. The slope of that revenue function is your marginal revenue. If they would have asked for the marginal cost, which they don't here, but if they would have, that would have been the slope of the cost function. Like I said, bunch of different names for slope. Marginal revenue, marginal cost, just asking for the slope. Rate of change, just asking for the slope. M, just asking for the slope. Does ask for some interpretation here. The interpretation just basically means that, hey, for each additional smartphone we have, we're increasing our revenue $89.50, which is the slope of that particular function. That's it. It's simple because it's linear. And thus completes 1.3. If you have any questions, reach out by email. Try your homework. And other than that, I will see y'all next class.